Let's look at exponential graphs. For example, let's sketch the graph of f of x is equal to 3 raised to the x minus first power minus 2. And then we're going to find any x or y intercepts of its graph. Let's use graph transformations to help us here. Let's start by sketching y is equal to 3 to the x. So if this is the y-axis, and this is the x-axis, what does y equal 3 to the x look like? Well, it has a y-intercept at 1, and then when x is 1, y is 3 raised to the first power, which is 3. So this is 2, here's 3. So we have the point 1, 3, it lies on the graph. And the exponential function looks like this. Now the x-axis, or y equals 0, is a horizontal asymptote. Now what does this minus 1 do here? What that does is it shifts this graph rigidly 1 unit to the right. That is, the graph of y is equal to 3 to the x minus first power. Looks like this. So here's the y-axis. Here's the x-axis. What's going to happen to this point over here, 0, 1, if we shift our graph 1 unit to the right? This is going to move to 0 plus 1, 1, or 1, 1. And what's going to happen to this point here, 1, 3? It's going to move to 1 plus 1, 3, or 2, 3. Now let's plot these points. This is x equal to 1 and y equal to 1. Here's our point 1, 1. And if this is x equal to 2, y equal to 3, then here's our point 2, 3. And the horizontal asymptote will still remain at y equal to 0, so our graph will look like this. Now what does this negative 2 do to this graph? What that does is it shifts this entire graph rigidly down 2 units. So let's say this is the y-axis, and this is the x-axis. What is going to happen to this point here, 1, 1? It's going to move to 1, and then 1 minus 2, or 1 negative 1. And what's going to happen to this point here, this 2, 3? It's going to move to 2, 3 minus 2, or 2, 1. So let's plot these points over here. Here is x equal to 1, y equal to negative 1. So here's our point, 1, negative 1. And then here's 2 and 1. So here's our point, 2, 1. Now the horizontal asymptote was at y equal to 0, which is also shifting down 2 units, which means that the new horizontal asymptote then will be at y is equal to negative 2. And so our graph looks like this. And let's darken these points we plotted. That is, this is f of x is equal to 3 raised to the x minus first power, and then minus 2. Now we're also asked to find any x or y intercepts of its graph. And looking at our graph, we see that we have a y-intercept here and an x-intercept here. So let's find these intercepts. To find the y-intercept, we set x equal to 0 in our equation. That is, we have y is equal to 3 raised to the 0 minus 1 minus 2, or y is equal to 3 to the negative first power minus 2, or y is equal to 1/3 minus 2, or y is equal to negative 5/3, which would be our y-intercept. That is, coming back over here to our graph, the y-coordinate of this point is negative 5/3. All right, and what about our x-intercept? To find our x-intercept, we set y equal to 0. That is, we have 0 is equal to 3 raised to the x minus first power minus 2, or 3 raised to the x minus first power is equal to 2. And now writing this in the equivalent logarithmic form gives us that log base 3 of 2 is equal to x minus 1. And now adding 1 to both sides gives us that x is equal to log base 3 of 2 plus 1, which would be our x-intercept. That is, the x-coordinate of this point here is log base 3 of 2 plus 1. And this is how we work with exponential graphs. Thank you, and we'll see you next time.